Okay, for just a second, let's talk about what it means for a car to depreciate 14% per year. So the car starts with a value of $20,500. If we lose 14%, we've got to find out what 14% of $20,500 is, and it looks like it's $2,870. So if we subtract that from what we started with, 20,500 minus, that's what remains after 1 year. Okay, and for the second year, we have to take 14% of that and then subtract whatever that was from 17,630 and so on. But an easier way to do this calculation is to ask how much remains. If we lose 14%, that means 86% remains. And you can see that 0.86 times 20,500 gives us the same number, 17,630. So when we create our exponential function, the value of the car based on time, this is the initial amount or the initial value of the car, 20,500, because when we put 0 into that function for t, 0.86 to the 0 power is 1. 1 times the initial amount gives us the initial amount. Okay, and so this is what remains. After 1 year, we put 1 in for t, 1 times 0.86. 0.86 times 20,500 gives us this $17,630. Okay, and you know, we could just keep multiplying by 0.86 for the number of years, and that's why we have this exponent of t sitting up here. After 1 year, 14%, and 14% of that is gone, or 86% of that remains, and so on. Okay, so now we want to know, when will the value be 7,900? Okay, so we put that in here, and we want to solve for t. This is an exponential equation. You usually solve exponential equations by taking the natural log of both sides. And by the way, here's some values. After 1 year, after 2 years, after 3 years, that's what remains. 4, 5, 6, we still have almost $8,300 in value. But after the 7th year, we're here. So we would expect the value to be 7,900 between 6 and 7. So let's see how that happens. So we take the natural log of both sides. Whoops. And guess what? I moved this to the wrong side. They should have been here. Take the natural log of both sides. Yeah, I got these all out of order. Sorry. Move the t down front by one of the power property of logarithms. Divide both sides by, here I just reduced this. Let me get rid of that. So 0.86t equals, wow, I got that all messed up. Natural log of 79 over 205 divided by the natural log of 0.86. Let's see if I can get these in the right order. Okay, so we took the natural log of both sides. Oh, I first divided both sides of the equation by 20,500. Then I reduced the 7,900 over 20,579 over 205. Then I took the natural log of both sides, moved this t down front, and then divided both sides by the coefficient of t, which is the natural log of 0.86. Okay, so there's the value of t, and here I show that it has a value of about 0.63. And if I put that into the table, there's the value after 6.322 years. Okay, there you go. Hope that helped. If you have any questions, post a comment.